What's up, math scholars and math haters? This is Mr. W. We are continuing the probability unit of discrete mathematics, and now we're coming to the idea of a permutation. The basic idea of a permutation is when you put a certain number of items in a specific order and you use each item only once. You can think of this like shuffling a deck of cards, or students getting in line for lunch or something like that. But there are three different ways to think about permutations. And the first one is just thinking about orders and arrangements. And so for this part, I want to start with a wholesome example of puppies at a puppy shelter. We have Spot, Sky, Snoops, and Steve. And we're trying to see how many different orders there are for them to all be adopted. Now, to go back to the fundamental counting principle, if we think about order, there's 4 puppies. So I'm going to make 4 blanks. And so we have which puppy's being adopted first, which one's being adopted second, which one's being adopted third, and which one's being adopted fourth. Now let's go ahead and say that Snoops is adopted first. So if Snoops is adopted, or actually, nope, cut that part out and start over. So for the first puppy to be adopted, how many possibilities are there? Well, if none of the puppies have been adopted, that means there's 1, 2, 3, 4 possibilities for picking the first puppy to adopt. Now let's say that's Snoops. So Snoops has been adopted. Yay, Snoops. Now for the second puppy to be adopted, we now have 1, 2, 3 possibilities left. Let's say the second puppy to be adopted is Steve. Someone decided they wanted a puppy with a human's name. Now for the third puppy to be adopted, there's just 1, 2 possibilities left. And let's say that Spot is next. Now Sky is the only puppy left to be adopted, and Sky is the only choice for the fourth puppy to be adopted. So now we would multiply all of these, 4 times 3 times 2 times 1, and that would give us 24 orders in which all 4 of these wonderful puppies can be adopted. So let's move on to the second example, and then we'll get to the formula part of this. And there's a particular vocabulary word. So the second example asks us to find how many different ways my grandmother can arrange 6 pictures of her grandchildren. And let's say that this is all on like a mantelpiece or something like that, or a nice shelf. There's 6 spaces that she can put pictures from furthest left to furthest right. Now, if we want to start by just going left to right, how many pictures can she put in the furthest left spot? Well, she has 6 pictures, so she can put 6 pictures in the furthest left spot. She picks one, she puts it there. Now, how many are left to go in the second spot? Well, if 1 picture has already been placed, that leaves 5. How about after she places 2 pictures? That leaves 4 to go in this spot. And I think you can see where I'm going with this. If she's already placed 3 of the pictures, 3 are left that can go in this spot. If she's already placed 4 of these pictures, there's 2 left that can go here. And finally, there's just 1 left that can go on the far right if she arranged them all from left to right. We multiply these together. And that gives us 720 possible arrangements. This is a lot. Now, you might have guessed that these numbers seem like they're increasing very, very quickly, and they are. And I actually want to get to a quick vocabulary or a quick symbolic notation part of this. And that is whenever you see an exclamation point next to a number. So in the first problem, this was 4 exclamation point, or 4 factorial, and that basically meant that we multiplied 4, 3, 2, and 1 all the way down. In this problem, it was 6 factorial. So we multiplied 6 times 5 and so on until we got to 1. This is the basic idea of orders or arrangements as it deals with permutations. And and the vocabulary word that you might hear, you might see for this, for the first problem, we could call it 4 factorial, and in the second example, 6 factorial. So if you've ever seen the exclamation point on a number before, that's not some trick teachers use to try to get you excited about math. That is an actual mathematical thing called factorial, which means that whatever number is to the left of the exclamation point, you multiply that number and every whole number all the way down to 1 altogether. So that's the first example of permutations. Now part 2 of permutations is where it gets a little bit trickier. You'll see problems like the 2 that I'm about to go over, and this will actually lead us to the big formula that you can use to find permutations for problems like this. Now this is going to be where you choose from a group and your order matters. And the first example I gave is that in an Olympic swimming race with 8 participants, we're trying to figure out how many ways there are to give out the gold, silver, and bronze medals. And gold goes to first place, silver goes to second place, and bronze goes to third. So we're trying to figure out how many racers can finish first, second, and third. So how many racers can finish first? Well, if nobody's finished, that means that all 8 racers are still going. So there's 8 possible racers who can finish first. But let's say someone does, and most likely it's Michael Phelps. That means that there are now 7 racers who can finish second and take the silver medal. And then once someone finishes second, now there's 6 possibilities of people who can finish third and get the bronze medal. So if we multiply 8 times 7 times 6, and for the second example, how many ways are there to give out 4 different prizes in a raffle? I wrote 2 for some reason. Anyway, how many ways are there to give out 4 different prizes in a raffle if 12 people entered? Since there are 4 different prizes, and I guess we also have to assume that no one can win more than 1 prize. I guess we'd have to assume that. Anyway, since we have 4 prizes, I'm making 4 blanks. First prize, second prize, third prize, and fourth prize. You'll see 324. So if no one can win more than 1 prize, there are 12 people who can take home the first prize. And after 1 person wins the first prize, there's 11 people who can take home the second prize. After 2 of those prizes are given out to 2 people, there's 10 people left who can take home the third prize. And then finally, you guessed it, there are 9 people who can take home the 4th prize after 3 prizes have already been given out to 3 people. So 12 times 11 times 10 times 9 gives us 11,880 different ways to give out 4 different prizes to 12 people who entered a raffle. Now, you might be seeing this. You might be seeing me do these 2 examples and think, hey, Mr. W, it looks like we're just starting a factorial thing without actually going through with it. And we actually are. So I'm going to go ahead and pull up the little board that I used to start this and talk about that formula. And you will see this written as NPR, the permutation of picking R things out of a group of N. And the formula for this is going to look like, we are going to start by figuring out what number or how many things we're choosing from and taking that factorial, and that's going to be divided by 1 more factorial, and this one of N minus R. So it's the number of things we're choosing from, we take that factorial, we divide it by the number of things we're choosing from minus the number of things we're choosing, we divide by that factorial. Now, how exactly does this work? Well, I'm going to pull up these 2 examples again. So for this first example, there were 8 racers and we were giving away 3 medals. So using the framework of that formula, NPR, also known as 8 pick 3, I start with my 8 factorial, I divide it by 8 minus 3 factorial, and this is actually going to allow me to see what exactly is happening. 8 minus 3 is 5, so we're dividing by 5 factorial. And on top of this fraction now, we have 8 times 7 times 6 times 5 factorial, all divided by 5 factorial. And if you know your rules about fractions, if we see the same number in the top and the bottom, we can actually get rid of those. So using this formula, we're left with the exact same numbers to multiply as when we just worked out the problem using the fundamental counting principle. Now, how does that work for this example down here? Well, this time we have 12 people to choose from, and we're picking 4. So I'm going to start with 12 factorial, the factorial of the number of things that I'm choosing from, or the number of people in this case. I divide that, and now I subtract 12 minus 4 and take that factorial. 12 minus 4 is just 8. So this could be rewritten as 12 times 11 times 10 times 9 times 8 factorial. Just like the above example, I can take 8 factorial and just cross it out from the numerator and the denominator. So essentially, if you want a little bit more of a shortcut, for the picking 3, I wrote out the first 3 numbers of my factorial. So basically, if you see 8 pick 3, you're starting your 8 factorial and you're writing the first 3 numbers. Down here, we started 12 factorial and wrote the first 4 numbers, 12, 11, 10, and 9.